How video games use the quadratic formula. Welcome to the vault. I'm MAHK and I've been making video games since the 20th century. So in case you've forgotten, a quadratic equation is an equation with an x squared in it. The quadratic formula is an expression that lets us calculate the solution. Let's look at an example of how we might use this in a video game. In a faraway galaxy, there's a coordinate grid with a planet right in the middle. At a different point in space, there's a planet-killing battle station. It's aiming its planet-killing laser at a point r units to the right and u units upwards. We want to figure out if the laser's going to hit the planet when it fires. To do that, we'll write equations for the edge of the planet and the path of the laser, and we'll solve for the points of intersection. For the planet, we'll write the equation of a circle using our old friend the Pythagorean theorem. For the path of the laser, we might be tempted to find the slope and the y-intercept of the line and write our line equation in slope-intercept form, y equals mx plus b. But that doesn't work for vertical lines, so it's not what video games typically do. So instead, what we're going to do is write separate equations for x and y in terms of a new variable called t. We can think of t as time. The laser fires at t equals 0 and arrives at its target point at t equals 1. With these three equations, we have enough information to solve for t. We just need to plug the top two into the bottom one, and then we'll have one equation with one unknown. Let's ignore the details for now. We end up with a formula with some stuff, some things, and some junk in it. The plus or minus in our formula means that the equation has two solutions, the entry point and the exit point of our beam. We only care about the entry point, and that's the one that's earlier in time. So for us, the plus or minus just becomes minus. Before we do anything else, we have to check the stuff under the square root. If it's negative, that means there's no real number that solves our equation, and we missed the planet entirely. We can stop right there. Otherwise, we solve for t, and then we plug it into our original equations to get the exact point of impact. There's still one more case we have to check. If the time of impact is negative, that means we're shooting in the other direction, and the planet is behind us. In 3 dimensions, our planet is a sphere, and we need to include the z-coordinate in our calculations. Other than that, the math is completely the same. As it turns out, this math is for more than just thin beams hitting spheres. We can also use it for spheres hitting each other. Let's imagine that our battle station is also a sphere, and instead of shooting, it's going to fly in a straight line. We want to figure out if it's going to crash into the planet or not. In that case, we just grow the planet's radius by the radius of our battle station and do the math as if the battle station were still a thin line. You can see how the moment of impact is the same moment that the center of the battle station crosses our bigger sphere. Okay, but what if the planet's also moving? In that case, we can just imagine that our coordinate grid is following the planet and use the relative path of the battle station. So once again, the problem reduces to one we've already solved. Because this math is relatively fast and easy, a lot of games will use spheres to approximate the shapes of things that are only sort of round. So if you've seen things hit each other in a video game, you may have seen the quadratic formula in action. Witness the power of my fully operational formula!